Very good morning, students. Today we'll discuss problems on oral transients. Mm, Either will be given with a diagram and then to find some current and voltage across the elements, or will be given it as a statement. Correct? Here statement is given. We have to draw the diagram for this problem. Initially relaxed series oral circuit. Initially relaxed. This is the keyword where the initial current through the inductor is 0. Okay, so initially relaxed means the current is 0, initial current is 0. Okay, so it's a series RL circuit, correct? With R value, L value is given, we have to draw a circuit for this one. The DC voltage 200 volt is applied at t equal to 0, correct? So for this I draw the diagram first. So we'll have a DC voltage of 200 volt, correct? It's a 200 volt. Then I'll have a switch, correct? This is R and an inductor, correct? So R value is equal to 100 ohm, L value is equal to 20 Henry, correct? So this is a circuit. Okay, so sometimes இந்த மாதிரி diagram கொடுக்கலாம், otherwise இந்த மாதிரி statement கொடுக்கலாம். இந்த statementல we are given with initially relaxed அப்படின்னா the initial current before closing the switch or after closing the switch is 0. Clear? So now there are 3 steps, correct? One is we have to form the first step is we have to write KVL equation. Second one, take Laplace transform. Third step, you take partial fraction of this. Okay, fourth one, inverse Laplace transform. If you do this 4 steps, correct, so we'll get the answer for any type of transient problem. Clear? Now we have a simple loop only. We can write the KVL equation for this one. The current flowing through this loop is, let us have I of t. Clear? And what we have to find out? Equation for current and voltage of different elements. What are the different elements we have? R and L. As R and L are connected in series, so I of t கண்டுபிடிச்சா போதும், which is same for R and L, correct? Then we have to find out voltage across the resistor and voltage across the inductor. This is A. B la we have to find out current at 0.5 second and 1 second. C, the time at which voltage across inductor and resistor are same. D, we are going to plot the current and voltage of inductor. Okay, so I have drawn first the circuit for the given statement. Then these are the steps I am going to follow, correct? First thing, okay, write KVL equation. Writing KVL equations. Okay, so it's a single loop, so you'll get only one equation. Clear? For that one you'll get 200. It's a potential raise, the remaining are drops, so 200 is equal to I of t into R plus L into di by dt. We know voltage across the resistor is I into R, correct? And then voltage across the inductor is L into di by dt. This is known to everyone, correct? Then this is the first step, correct, as I said earlier. Then what you have to do, second step is take the Laplace transform, correct? So step let us have step 1, step 2, taking Laplace transform of the above equation. Okay, so you'll get for constant, no, 200 divided by S for constant. Clear? Then is equal to R value we know, which is nothing but 100, correct? So 100 into IFS plus L value also we know, just substitute. So taking Laplace transform of a differential equation, we'll get as S IFS minus I of 0 minus. So I of 0 minus is current before closing this switch. I of 0 minus or 0 plus or simply I of 0, all specifies the same thing. Clear? So initial current through the inductor, that value is 0. So this value is 0 because it is initially relaxed. That is the keyword given here, correct? So what we get here, 200 by s is equal to 100 I of s plus, as it this is 0, 20 s into this is multiplication, okay, I of s. So I of s is common for this, so you'll have I of s common. So what we get, 100 plus 20 s, okay, 200 by s. I need only I of s, so I take I of s one side, இது இந்த பக்கம் போச்சுன்னா டினாமினேட்டரில் வரும், கரெக்ட்? 200 டிவைடட் பை எஸ் இன்ட்டு 100 ப்ளஸ் 20 எஸ், கரெக்ட்? ஐ நீட் த திங், இந்த 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 டேர்ம் வந்து எஸ் ப்ளஸ் ஏ அப்படின்ற ஃபார்மேட்டில் இருந்தால் தான் இன்வர்ஸ் லேப்லாஸ் நம்ம எடுக்கிறதுக்கு ஈஸியாக இருக்கும். ஸோ ஐ டேக் திஸ் 20 as காமன், ஓகே. வெளியே எடுத்துட்டோன்னா 200 டிவைடட் பை 20 multiplied by s multiplied by 100 divided by 20 plus s, correct? So what you get? So 5, not 5, sorry, 1, 10, correct? 10. So I can consolidate this equation as I of s is equal to, correct, 10 divided by s into this is s plus 5, s plus 5, correct? Now I have got I of s as 10 divided by s into s plus 5. So after this, what is the third step? We have to go for partial fraction, correct? Fourth step is inverse Laplace transform. Now as this is having two distinct roots, correct? So this is having two distinct roots. So how can I take partial fraction as a by s plus b by s plus 5. So I have to find out a value and b value. So a value is its root s into I of s. S is equal to 0, correct? At s is equal to 0. S into இந்த partial fraction எடுக்கிறதுக்கு முன்னாடி இருக்கிற இந்த வேல்யூ தான் யூஸ் பண்ணணும், ஓகே. 10 divided by s into s plus 5 at s is equal to 0. So s gets cancelled. If you substitute s is equal to 0, you'll get this as 10 divided by 5, which is equal to 2. So a value is equal to 2, correct? Then we are going to find out b value. To find out b value, b oda denominator la enna irukko adha eduthukkanum. S plus 5 multiplied by I of s and its value s plus 5, no? So what is the root of this one? S is equal to minus 5, correct? So I substitute s plus 5 into I of s value 10 divided by s multiplied by s plus 5 at s is equal to minus 5, correct? S plus 5 cancel aidum. So b is equal to 10 divided by s is there. So 10 divided by s value is minus 5. So if you cancel this, you'll get minus 2. So b is equal to minus 2, correct? So then you substitute this I of s is equal to in this equation, correct? So a value is 2, so 2 by s. B value is minus 2, since I take minus 2 divided by s plus 5, okay. So this is the third step, correct? What is the fourth step? Step 4, take inverse Laplace transform. Taking inverse Laplace transform, okay. These 4 steps are common for any transient problem, okay. Keep that in your mind. So if you take inverse Laplace transform, we will get I of t. So 2 by s means 2 minus 2 e power of minus 5t. So we know Laplace transform of 1 divided by s plus a. Hope you remember this formula, e power of minus at, correct? So Laplace transform of any constant, if it is 5, means you'll get 5 by s. Similarly, if inverse Laplace transform of 5 by s is 5, correct? So I of t, 2 is common, so 1 minus e power of minus 5t. This is the current equation, correct? So our first question is V and I of each element, correct? Voltage and current for each element. How will you find out voltage and current? As I already told, this is a question, correct? Current through R and L are same, correct? As they are in series. So I of t in resistor, which is equal to I of t in inductor, is equal to 2 1 minus e power of minus 5t. Okay, then voltage. Then suppose if they ask voltage in across each element, voltage across R, so I'll mention this as VR, correct? VR is equal to I of t into R. I of t we know R value is 100, correct? 100 into I of t is 2 into 1 minus e power of minus 5t. Okay, so if you use this, VR is equal to 2 into 100, 200, 1 minus e power of minus 5t. This is the voltage across the resistor, correct? Then similarly we have to find out voltage across inductor. Okay, so for voltage across L, so I'll specify it as VL. We know L into di by dt. L value is 20, correct? Di by dt, so differentiate the values of 2 into 2 minus 1 minus e power of minus 5t, correct? So what we get 20 differentiation of these two. If you take 2 inside or we can take it at outside, correct, as it is a constant, then differentiating this one becomes 0, then we'll get 1 minus, correct, I'll put within bracket. If I differentiate e power minus 5t, I'll get minus 5, correct, into e power of minus 5t, correct. Then this minus minus becomes plus, minus into minus plus. 2 5s are 10, 10 into 20, 200. So the answer is 200 e power of minus 5t is the voltage across inductor. Okay, VL is equal to 200 e power of minus 5t. Okay. Then B question is, what is current when t is equal to 5 millisecond, 0.5 second and 1 second, correct? We know I of t is equal to 2 into 1 minus e power of minus 5t. Okay, so at t is equal to 0.5 second means I of t is equal to 2 into 1 minus e power of minus 5 into, how to put, 0.5. Okay, if you substitute this value, we'll get as 1.83 amps. Hope you know how to operate your calculator for this one. Okay, so if not, I just show it, so how I do it. Okay, so first I'll make use of this component e power of minus 5, so shift. Okay, so E, go for shift E of parenthesis minus 5 into 0.5, correct? Okay, I'll get this answer, then 1 minus answer, okay, multiplied by 2, clear? 1.835 or 1.84 amps. Okay, so I rounding off this one as 1.84 amps. Okay, then so at t is equal to, then again t is equal to 1 second, I of t is equal to 2 multiplied by 1 minus e power of minus 5 into 1. If you substitute this one, we'll get this as 1.986 amps. Okay, so the third one, that is C. What is a C question? We have to find out time at VL, voltage across the inductor, and voltage across the resistor is same. We have already calculated voltage across inductor and capacitor, correct? What is that voltage across inductor is we have calculated, see, VL as 200 e power minus 5t, VR is 201 minus e power minus 5t. Okay. Okay, now 200 gets cancelled. We will get e power of minus 5t is equal to 1 minus e power of minus 5t. So if it comes this side, I will get 2 e power of minus 5t is equal to 1, then e power of minus 5t is equal to 1 by 2, correct? So I need to cancel this e, so that what I can do, 5t is equal to taking natural logarithm on both sides, ln of 1 by 2, correct? So I use calculator for ln of 1 by 2. So ln of, I'll do this, ln of 1 divided by 2, correct? What I'm getting, minus 0.693, correct? So minus 5t is equal to minus 0.693. So I need t, so divided by minus 5, correct? So I'll put the same answer, divided by minus 5. So I'll get 0.139, correct? So t is equal to 0.139 second. Okay, so at this time voltage across the inductor and capacitor will be same. Now last case, D is equal D. Plot the graph for voltage across the inductor and current, correct? So we know this, let us have this time, correct? So VL is equal to 200 e power of minus 5t, correct? Then I of t is equal to 200 into 1 minus e power of minus 5t, or sorry, 2 into, correct? 2 into 1 minus e power of minus 5t. So 1 minus, so 1 minus exponential decreasing means we'll get this type of waveform, correct? This is I of t waveform, and then similarly the voltage waveform is this one, VL of t, voltage across the inductor. Okay, thank you all for watching this.